Hello grade 12s and welcome to this video in which we will be working through question number 4 from the November 2021 Physical Science Paper 1 exam. This question deals with momentum and impulse and also specifically with an elastic collision. I'd like to remind you that on your formula sheet under the word force or the heading force, you're going to see the formulae that you can use in this section. We have the formula to calculate momentum. We have the momentum impulse theorem, which can also be manipulated to give you Newton's second law in terms of momentum, and they show us how we can calculate the change in momentum. Question number 4 reads, a ball X of mass 10 kilograms is moving eastwards with a velocity of 2 meters per second. It collides elastically with another ball Y, of mass 2 kilograms, which was moving with an unknown velocity which we are going to call Vy. We can consult diagram A to see a visual representation of what has just been stated. Then they say, immediately after the collision, ball X comes to rest and ball Y moves eastwards with a kinetic energy of 36 joules, and we can see this in diagram B. I'm going to go and label each of the values that we see in the diagrams. We know that this is V initial of ball X, Vy is the initial velocity of ball Y, which we don't know its magnitude. In the end, we know that ball X is going to have a final velocity of 0, and the 36 joules that has been given to us is the final kinetic energy of ball Y. So this is at the end of the collision. We're going to write down over here on the sketch that ball X has a mass of 10 kilograms, that we do not forget that this is information that has been given to us. And we're going to write down that ball Y has a mass of 2 kilograms. Now that we've listed all of the information given to us, I would just like to emphasize that they use the words eastwards in order to describe direction. So it is important that we use compass directions. In this case, it would be east and west when we give our answers. Please remember that momentum is a vector quantity, and we calculate it using velocity. So if we are looking at a formula like P equals mv, the V value that we substitute in will be positive or negative dependent on which direction we choose as positive or negative. And when we get our answer, it's important that we give it direction or we may lose our final mark. On that note, we need to decide which direction we're going to choose as positive. I'm going to go ahead and choose east as the positive direction, and we're going to stick with that throughout the video, but you're more than welcome to choose west as positive instead. Question 1.4 says, explain the meaning of the term elastic collision. An elastic collision is a collision in which both the total momentum and the total kinetic energy are conserved, or you can say are kept constant. Now grade 12s, you will only obtain the 2 marks possible for this question if you state the underlined parts correctly. So if you say it is a collision where the total kinetic energy is conserved, but it is true that the total momentum will be conserved as well. I'm going to write this down in symbol form because that may be useful to us at a later stage. So this is going to give you your 2 marks for writing this down, but I would like to just remind you of what this means. If the total momentum is conserved, then we are dealing with the principle of conservation of linear momentum, which says that the sum of the momentum before the collision is equal to the sum of the momentum after the collision. If we are looking at the total kinetic energy being conserved, then you are saying that the sum of the kinetic energies of objects in the system before the collision is going to be equal to the sum of the kinetic energies of the objects in the system after the collision. Now you can see I've inserted screenshots from the formula sheet. And the reason I'm doing so is not because these principles are stated on the formula sheet, but because I often find that learners make mistakes and think that this formula is the same as this one when they are not. The one at the top is for conservation. The one that I have written down, that is for conservation of kinetic energy, or in other words, for elastic collisions. If we would like to prove that a collision is elastic, we will add up the kinetic energies before the collision, then add up the kinetic energies after the collision and see if they are equal. We are adding together, we are finding the sum of the kinetic energies. On your formula sheet, however, this formula is for change in kinetic energy, which is what we use when we make use of the work energy theorem. Please do not confuse the two and take note of the fact that this principle is not stated on your formula sheet. I've seen many learners use the wrong formula because they assume that it means the same thing. When it comes to this formula over here, or this equation, which is the principle of conservation of momentum, this principle is also not given on your formula sheet. The only thing that is given to us is the formula for momentum. And a big mistake that I see learners sometimes do is, instead of just saying mv, they go and put a square on the v, because they're so used to perhaps using the formula for kinetic energy. Grade 12s, please avoid making unnecessary mistakes. Familiarize yourself with your formula sheet and always go back to look at your formula sheet to make sure that you have written down your formulae correctly. Question number 4.2 reads, calculate the velocity of Vy. That is ball Y's velocity before the collision. Whenever you see the words collision, and you find that objects are colliding, I want you to start off by thinking about conservation of linear momentum, because this is the very first formula you ever dealt with that spoke of collisions. Most of the time we teach this before we even teach the difference between elastic and inelastic collisions. So we know, based off of this, that somewhere in this calculation we will most probably make use of the principle of conservation of linear momentum. This question is out of 5 marks, and although marks don't always say or give a very clear indication of what you should do, we can sort of assume that we may need to perform more than one calculation in order to obtain the 5 marks. When we write down the principle of conservation of linear momentum, it is as follows. We say the sum of the momentum in the beginning is equal to the sum of the momentum in the end. So momentum, linear momentum, is conserved. If we expand this for ball X and ball Y, then we will have the mass of ball X multiplied by the initial velocity of ball X plus, because it is the sum of the momenta, the mass of ball Y plus the initial velocity of ball Y, which I'm just going to call Vy because that is what they labeled it as, is equal to the mass of ball X multiplied by its final velocity plus the mass of ball Y multiplied by its final velocity as well. So this is the principle of conservation of linear momentum. Let's see what we have. We know that we have the mass of ball X. We also have the mass of ball Y. We know the initial velocity of ball X, and we know that at the end it comes to rest. Now we are looking for this velocity, but we have 2 unknowns in this equation so far. So the question is is it possible for us to calculate or determine the final velocity of ball Y? Well, we were given the kinetic energy of ball Y. So how about we use the formula for kinetic energy in order to determine the velocity of ball Y after the collision? The formula for kinetic energy is EK equals half mv squared. And please do not confuse this formula with the formulae that we use to calculate momentum. Yes, we have an m multiplied by v, but with kinetic energy, there's a half right in the front, and the v, the velocity, or rather the speed, is going to be squared. So in this case, we're going to plug in the value that we know for the kinetic energy. It is 36. So we plug in the 36 is equal to half. The mass of this ball is 2 kilograms, and we're looking for the speed. We move or divide by the half times 2, and then we take the square root, and we find that the velocity is, or the speed rather, is going to equal to 6 meters per second. This here is the final velocity or final speed of ball Y. The reason I keep switching between the words speed and velocity is because kinetic energy is a scalar quantity. So technically speaking, when we get our final answer, it is speed, or rather it's going to just be the magnitude of the velocity. When you use this formula for kinetic energy in order to calculate the value of V, the answer that you get does not come with a direction. So it does not tell you what the direction is. You may remember in mathematics, when we take the square root, we write plus or minus at the front. So we now need to go back to the situation in order to determine in which direction this ball Y is going to move. They say, after the collision, ball Y moves eastwards, and we have chosen eastwards to be positive. Therefore, we are going to say that the velocity is positive. So it's positive 6. Now that we have all of these values, we can substitute them into the formula. The mass of ball X we determined, or rather they gave us, as 10 kilograms, so we write that down. 10 is equal to the initial velocity is positive 2 plus the mass of ball Y is 2 kilograms. We do not know Vy, that is what we're trying to find. The mass of ball X is 10, and in the end, its final velocity is 0 because it comes to rest. We write down plus the mass of ball Y is 2, and remember we just calculated or determined its final velocity, which we said is eastwards, and we therefore substituted into this formula as a positive 6. When we manipulate this equation, we find that Vy is equal to negative 4 meters per second. Now the negative is, well, something that we should not ignore. The negative gives us direction. We know that we have chosen east to be the positive direction. So we're going to expand on this and say this means 4 meters per second toward the west. If positive is east, then it means the negative direction is towards the west. For a calculation like this, you're going to obtain marks as follows. Unfortunately, you're not going to obtain any marks for this calculation if you used this method. But you are going to obtain 1 mark for writing down the principle of conservation of principle of conservation of linear momentum. So this equation, you're going to get 1 mark for everything that you substituted on the left, 1 mark for everything that you substituted on the right, 1 mark for the magnitude of the velocity Vy, and 1 mark for giving the direction. And giving the direction is something that many learners skip because you're in such a rush that you forget velocity is a vector quantity and therefore needs direction as well. So please, grade 12s, be very careful if you're asked, especially in this section, to calculate velocity, and they don't say the magnitude of the velocity, then you must give direction as well. This calculation will give you 5 marks. Now, there are different methods or other methods that you may use to calculate exactly the same thing. As mentioned previously, you are welcome to go and see the exam guidelines to familiarize yourself with the other possible methods. We are now on the very last problem of question number 4, and also the last problem we will work through in this video. And this problem starts off with some new information. They say the balls were in contact with each other for 0.1 seconds during the collision. This is time that has been given to us. Now they say calculate the magnitude of the force that ball X exerts on ball Y during the collision. So this force that X exerts on Y is going to be the net force, because there are no other forces that will act on ball Y that are parallel to the surface. Okay, so this is going to end up being the net force. The focus here is ball Y. So we would like to know what ball Y is going to experience. I'd like to now bring your attention back to the formula sheet. If you look at the values that I have, highlighted in a sense when we read the information, you will see time and the net force. The only formula on your formula sheet, especially in this section, that involves the net force and time is this one over here, the impulse momentum theorem, the formula for the impulse momentum theorem. F net multiplied by change in time is equal to change in momentum. And we can expand the change in momentum to mv final minus mv initial. So any form of this formula, if you write down either the first version or the second version, you're going to get your formula mark. We now check which of these values do we actually know. We know the time, and of course we know the mass of the ball Y. But do we know its initial and its final velocity? The correct answer is in fact yes. Yes, we do. In the previous problem, we worked out the final velocity of ball Y to be 6 meters per second. And in the end of that question, we found the initial velocity of this same ball to be -4 meters per second, where the negative refers to the direction. So since we have this velocity value and that one, we're now in a position where we can calculate the net force. Let's substitute all the values into the equation. We say F net. We substitute into this the time which has been given to us as 0.1 seconds is equal to the mass of the ball is 2 kilograms, its final velocity is 6. Minus 2 kilograms, its initial velocity is -4. Please do not forget the direction or you're going to lose your marks. There are so many learners who lose marks purely because they forget to substitute in the direction as well. Now we manipulate the formula, and in the end, we find that the net force is going to equal to 200 newtons. That is the magnitude of this net force. You will see in this specific formula, I used the mass and velocities of ball Y. And the reason I did so is because ball Y is the ball that is experiencing the force. But you will soon realize if you do the calculation using ball X's mass and its velocities that you're going to get exactly the same answer in terms of magnitude, of course. Now, why is it so? Why will we find that the net force experienced by Y has the same magnitude as the net force experienced by X? Well, this is based on Newton's third law. And therefore, because of Newton's third law, you could have actually focused on ball X, found the magnitude of the net force that X experiences, and you would get full marks for that because the net forces are equal to each other in magnitude but opposite in direction. Now, if you do your workings for ball X, in the end you're going to find the net force is equal to negative 200 newtons. So there's going to be a negative at the front of your answer. But the question only asks for magnitude, right? So you will then have to go further and say, therefore, the magnitude of the net force is equal to 200 newtons, so that the marker knows that you know the difference between magnitude and the actual vector called force. Grade 12, for this, you're going to get your marks as follows. You're going to get 1 mark for your formula. You could use either version of the formula and you'll get your marks. You're going to get 1 mark for your substitution into the formula and 1 mark for your final answer. That's going to get you the 3 marks for question 4.3. This brings us to the end of this video. This question, by the way, was out of 10 marks. In the next video, we're going to look at question number 5 of this 2021 paper. Question number 5 deals with the work, energy, and power section of physical science, which I know a lot of learners find challenging because there's so many different formulae in that section. So I do hope that you will join me in that video. All the best. I hope to see you there.